Minasan, konnichiwa, Samurai Engineer desu. In this video, we will solve problem number 2 of our rational functions. So, we are being asked to solve for domain and range, zeros, vertical asymptotes, and horizontal and oblique asymptotes. So, our given for problem number 2, let us write. So, we have y is equal to x squared plus 5x plus 4. So, x squared minus 2x minus 3. So, these are the given. So, let us solve for problem number 2. So, it looks like this, no? So, we have the following. So, let us solve for the zeros. So, zeros. So, that is numerator. So, numerator x squared plus 5x plus 4 is equal to 0. And therefore, we can what? We can factor out x plus 4 and x plus 1 is equal to 0. Therefore, we have values for zeros. Using this, therefore, x must be equal to negative 1 and negative 4. Because of this, no? X plus 4 is equal to 0. Therefore, x is equal to negative 4. X plus 1 is equal to 0. Put the 1 to the other side, x is equal to negative 1. So, just like this, we can verify. So, if you put negative 1 to the other side, x plus 1. If you put negative 4 to the other side, x plus 4. So, that is here. Okay? Those are zeros. How about the whole? The denominator, x squared minus 2x minus 3. So, we have to equal it to 0, and that is actually x minus 3 and x plus 1, no? X minus 3 and x plus 1. That is the factor. So, by factoring, no? So, negative 3, that is negative 3 times 1 is negative 3. Negative 3 plus 1 is negative 2. So, that is our factor. And that is equal to 0. Therefore, the answer is our holes are, there are two holes. X is equal to negative 1 and 3. Again, x plus 1 is equal to 0. Put to the other side, negative 1. X minus 3 is equal to 0. Put to the other side will become positive. Again, and next objective is to try to so we have to try to sketch by using values. Okay, use values so you can put values on this equation, on this rational function. So we can what? For example, if x is equal to 0, 0, 0, 4, 0, 0, 4 divided by negative 3. So about negative 1 point. So that is at x is equal to 0. No? So we have, for example, here. So at x is equal to 0. So this is, for example, 1, 2, 3. Or let us put that as 2, 4, 6, negative, negative. 2, 4, 6, positive, you know. So let us imagine So, negative, 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 negative. Negative 2, negative 4, negative 6, negative 8. Okay, like that, no? So, if we have a graph, so we have what? If x is equal to 0, we have negative 1.3. So, negative 1.3. So, we have here, point. We have a point here. No? So, that is a point. So, also we have zeros at x negative 1 and negative 4. Negative 1, this is the negative 1, that is a 0. And negative 4, that is another 0. Okay? And we have what? And we have a hole at negative 1 and negative and positive 3. Positive 3, we have a hole here and negative 1. So, take note. So, negative 1, negative 1. So, we can actually cancel out this one. We can actually cancel out this one and this one. So, we can actually, but that is, even if we cancel out, we have 0 and whole here. So, it will cancel out here. So, in negative 1, di ba? So, we have negative 1, negative 1. It will cancel out. Because we have whole and we have 0. It will cancel out. But, look, what will left behind will be x plus 4 and x minus 3. Oh, this is now our, however, this is our problem, not this one. So, take note of this. This is our function. This is our equation, not this one. This is a simplified form of our equation. Simplified form. Simplified because we don't have x plus 1 on the numerator and denominator. We already canceled out. Okay? We cancel out numerator and denominator x plus 1. Okay? But in actuality, they are there. So we just have to what? So we have what? X plus 4 is a little bit greater than x minus 3. No? So whatever the value of this, the numerator is always a little bit greater than if the value, for example, is positive. No? So for the positive values, okay, so it becomes constant. No? So for example, uh, for example, we have an asymptote. Where is the asymptote? It's negative 1 and 3, positive 6. So, we have asymptotes here. Let us verify if we actually have asymptotes here. So, we have what? Here and here. No? We have, okay, asymptote. So, therefore, we can solve the value of the function at x is equal to 4. Let us solve. 4. Okay, calculator. 4 squared is 16 plus 20. 16 plus 4 is 20. So 20 plus 20 is 40. 40. We can actually use this. No? 4 is 8. 4 minus 3 is 1. So 8 over 1. No? So that is 8. The value of y is 8. The value of y is 8 at x equal to 4. So that is here. No? Value is 2, 4, 6, 8. Positive 8. So we have the value here. That is the value at x is equal to 4. So very big value. Okay. How about if x is equal to 2? 2 plus 4 is 6, negative 1. So 6, so negative 6. Immediately it becomes negative 6. So this is negative 6. So this is the value. Okay, so this is a whole. Okay, so we can find that this is not a straight line, no? This is positive 8. This is positive 8. This is negative 6. This is not a straight line. This is not a straight line. This is somewhat this is not a straight line. How about x is positive 1? So 5, negative 2. 5 divided by 2 is negative 2.5, no? Negative 2.5. So negative 2.5 is somewhat here, no? So this is the shape. Okay. We need more. We need more. We need more. How about x is equal to 0? That is, we already know, no? Here, no? So we already know here. Somewhere here. Okay. Okay, like that. No? So this one maybe is not an asymptote. No? Maybe this is not an asymptote. This is just a hole, and so this maybe is an asymptote. So let us put the value 2.5. So what is the value if we have 2.5? So let us have a calculator. Where are you? So, calculator. So we don't have a calculator. Here, let us use the Excel. Okay. So let us use Excel. Okay. Let me